I'm again here with you all to discuss few more topics which are left in chapter motion in straight line of class 11. Okay. Today we are going to discuss about instantaneous speed and instantaneous velocity. And after that, if we will have time, we shall continue further. Let us see. See, here instantaneous. The term instantaneous refers to the instant, to the particular instant of time. The particular instant of time. That means the velocity that a body is posing at the time of its motion, just at a particular instant, that is called instantaneous velocity or instantaneous speed in case of speed. Okay. So here, suppose if I am telling you that velocity of a body is delta x upon delta t. So this is what? This is average velocity. This is average velocity. Now if I have to find instantaneous velocity, so for instantaneous velocity I have not to see any time interval. This time interval should be 0. That means at particular instant. So for that we will apply limit delta t tends to 0 and this will become delta x upon delta t. This will become the formula for the instantaneous velocity. Actually delta t tends to 0. This means that t time interval is infinitesimally very small. Okay, for very small time what is the displacement that will be giving you instantaneous velocity? Well, unit will have no any difference, and units of instantaneous velocity, instantaneous speed, speed of velocity or average speed and average velocity all will be same, that is meter per second. Other units can also be converted. So this is instantaneous velocity. Yes, in other terms or in other language you can also write that instantaneous velocity is equal to dx by dt. Here where we can say that dx by dt is differentiation or differential coefficient of x with respect to time t. Alright, this is what is instantaneous velocity. Now you may ask, what is instantaneous speed? It is very simple, that magnitude of the velocity. Okay, magnitude of the velocity at a particular time, that is only the instantaneous speed. Got it? So here let us see. In simple term, we can say that in simple term we can say that instantaneous velocity is the velocity at a particular instant, for uniform motion average velocity is same as velocity at every instant. Now you can try to understand graphically, but it is quite difficult to represent the instantaneous value graphically. Then also I am trying you to explain it. Okay, let us see. Very small graph I will be plotting here. See, here I am taking time t, here I am taking x. Suppose the body is moving like this. Between these two time interval, the body is having this displacement. Okay, this is the displacement delta x for this much time, that is delta t. Okay, now if I am going to reduce the time interval, I am going to make it very small, make it very small, then you can say that delta x will become also somewhat smaller. A time will come when this gap, the gap which you are seeing here, I am coloring it. Okay, this gap becomes, this gap only delta t becomes tends to 0, at that time the value which we will get here itself, that will be instantaneous velocity of the particle. Here x is the displacement and while t is the time taken for the given displacement. This is the graph. Okay. See, this is the case of uniform motion. Now I will be explaining you one question on the basis of the formula V instantaneous is equal to dx by dt. So we have the question here. The position of a particle changes along x-axis with respect to time as per equation x equal to 2t square plus t plus 3. Find the velocity of the particle at t is equal to 0 second, t equal to 1 second and t is equal to 2 second. How to solve this one? Well, see here, the position is given. It is given that position is changing as per the equation 2t square plus t plus 3. Now you all must know that formula that we will use here, that is V is equal to dx by dt. Now one may ask, what is this? How to solve dx by dt? Well, I will tell you that d by dt, if here t times t to power n is given, then the result will be n t to power n minus 1. Here, this one will be explained in mathematical tools of physics. Okay, you must know this. This is the differentiation of t to power n with respect to t. That was the formula. Now if here x comes, here also x comes, now what will happen? The power will be multiplied and one exponent will be reduced by 1. Okay, so let us see here what happens. If I see velocity is equal to dx by dt, then I can put here d by dt of 2t square plus t plus 3, and you will get here 4t plus 1. Okay, this is the velocity. Now put the value of t is equal to 0, t is equal to 1 and t equal to 2 to get the desired result. Well, I will explain you here. At t is equal to 0 second, velocity, that is 4 into 0 plus 1, it is equal to 1 meter per second. At t is equal to 1 second, velocity is 4 into 1 plus 1, it becomes 5 meter per second. At t is equal to 2 seconds, velocity is equal to 4 into 2 plus 1, and that comes to be 9 meter per second. So once again, I am trying to make you explain about this. Position is given here. You have to differentiate all these terms with respect to t. On differentiation, you will get this value. Now, how to differentiate it? This is very simple task. See, I am just explaining a little bit about that here. How to differentiate? See here. Suppose you are given y is equal to d or y is equal to x to power n. Now I say you that find dy by dx. So this is just like this, that d by dx of x to power n. In place of y, I will replace x to power n, and you will get that dy by dx is equal to n x to power n minus 1. Okay, this is the formula used. Right. Now suppose if here any constant comes like 3. So for 3, dy by dx will be 0. Okay. Well, if you need it, I will explain it in another section, explaining about mathematical tools related to differentiation and integration, which are being used very frequently in some of the chapters of part 1, even in some chapters of part 2 also. Well, so this is a question related to instantaneous speed and the velocity. Okay. Well, instantaneous speed is the magnitude of the velocity. Once again, I am repeating it. Keep it in mind. Okay. Next topic will be acceleration, and I am going to discuss it now. See, the term acceleration tells about how faster or how slower the velocity of a body is changing. Okay, when a body moves, at that time velocity sometimes may remain constant or may not remain constant. Okay, so velocity will change, and if it changes, then what happens? That may have positive acceleration or negative acceleration. Now, first of all, you have to understand what is acceleration. Well, rate of change of velocity with respect to time is called acceleration. So here you can just write it as rate of change in velocity with respect to time. That is acceleration. It is very simple. You can write A, and acceleration is always, if suppose changing, suppose body is accelerating, at that time you can say that it is equal to dv by dt, right? It is dv by dt, or change in velocity per unit time. Even you can also write acceleration equal to velocity at different time t2 and yes at t1. So you can get like this also. Acceleration formula, it is time interval. You can represent it this as t also, no problem. A is equal to v2 minus v1 divided by t2 minus t1. Well, this one will be explained in kinematics of equations. Okay. Well, this is the acceleration, and you know well that its SI unit is what? That is meter per square second. Okay, meter per square second. This is the acceleration of the body. Now, what is the meaning of positive acceleration and what is the meaning of negative acceleration? Let us see. Positive acceleration means when a body is in increasing speed or increasing velocity, at that time we say that body is in positive acceleration. But brake is applied over the body, okay, to stop it. So there is retardation, that is negative acceleration. That is negative acceleration. All the things that are related to study with graph will be covered in another section, another video lecture. Are you getting it or not? So here, what is acceleration? It is very clear to you. So I will be discussing few of the graphical things related to position time graph, velocity time graph, and about positive and negative acceleration in our next video lecture. Till then, must revise all the things to get to the point very well. In case of any doubt, do comment in the comment section and let me know what kind of problems you are facing, and if any kind of improvement or suggestions are there, you are kindly invited to do or to say all these things in comment. Thank you.